Thank you, everybody. Thank you for the opportunity to be here. It's indeed a great pleasure to be here at the launch of Ashoka's Climate Change Center. I'm delighted to hear about it. I have about 25 minutes to speak, and what I'm going to do is talk about India's multiple transitions amid a changing global climate, and hopefully be able to draw a little bit from the two excellent speakers we had before, but also shed some light on what this means in the sort of larger social political context. So how I'd like to spend this time is to first talk about the global climate change predicament. It's a lot of this are things that you might have heard already in this session, but also otherwise. I'd then like to locate India in the broader energy and climate context. I'd then like to move to mechanisms for how we get to the sustainable development world. So to sort of think a little bit about tipping points, because that's sort of been a theme, especially in Tim's talk, but also talk about the interconnectedness between what is considered individual change and systemic change. And I'll be empirically specific in terms of referring to the changing household energy services in the Indian context. And then pose some difficult questions as we look ahead. So let's take a step back and sort of look at where we are, where our current predicament is in terms of the long planetary history that we're all part of. And Tim showed us some excellent slides about this. Just to reiterate the same point, the idea is that if we look back 400,000 years, we are in this sort of cycle of raising CO2 concentrations and then dropping concentrations, but never have we reached the concentrations that we have in the last 1,000 years. So if you zoom in to those last 1,000 years, and you see that in the sort of box image that is on the top of this graph, you see how quickly emissions have risen, crossing 300, crossing 350, and beyond parts per million. And this has all happened in the last couple of 100 years. So this is higher than has ever been seen in any previous interglacial period. And while it's something we know, it's interesting to me always how there are certain facts, scientific facts that we're always resistant to grasp. And to me, this is one of those. Now, it's every time I think about these emissions, I think it's very important to ask who is responsible, because the moment we start asking the question about what we do about climate change, there is this question of responsibility that crops up. And I think sort of avoiding that question is problematic. Answering it is equally problematic, but it requires addressal. So if we look at this graph here, what we have is, this tells us the emissions on an annual basis. So every year, going back to 1751, what were the annual emissions of the top 5 countries, or the top 5 annual emitters? And we see here that there's been this slow rise in who the largest annual emitters were. And up to the last 2-3 years, this was China, the United States, EU, India, and Brazil. And so India is sort of, is up there in terms of the top annual emitters. And that's why there's a focus on these countries every time we have these conversations about climate change. But responsibility is an interesting thing. It's complex. And if we look from the vantage point of emissions per person, there's a very different story to tell. So the graph here tells us about the emissions that are used per person in each of these countries. And if you look at the numbers here for those very same countries, there's been a sort of rejuggling of order. And indeed, the United States is up very different places on this pecking order, and India is actually much lower than the global average. And so I think it's important for us to hold that context of responsibility and where these emissions have come from into our atmosphere as we take this conversation forward. Now, how have we tried to address this problem globally? And this is, sort of, again, is one of those issues where we sort of need to think about our resistance to these scientific facts, which we've now known for a very long time. So the first International Climate Change Conference was about 30 years ago. And this was in Rio, where different nations signed the United Nations Framework Convention for Climate Change to prevent dangerous anthropogenic interference with the climate system. The first COP, which was in 1995. We have a big COP coming up in Glasgow later this year, but the first one happened in 1995, which again was decades ago. And since then, we've emitted many billion tons more of carbon dioxide. As Tim told us, mean surface temperatures are now is now sort of 1.1 degrees above the pre-industrial world. And the estimates are that we're basically increasing our temperatures at about 0.2 degrees Celsius per decade. So this is faster than ever before. And at the rate we're going, this is very sobering. We could reach the 1.5 degree limit, or the limit that is laid out in the Paris Agreement, anytime in the next 10 years, or sort of the next up to 2050. So the idea that we're so close to hitting that number is indeed sobering, given that we've been thinking about how to address this problem for at least 30 years. Now, the Paris Agreement has helped us in providing a way through to, sort of through this conundrum. And one of the ways it's done that is that it enables countries to put forward what is called a nationally determined contribution, which is an ambition for a country or a contribution that a country makes as a pledge. And each country decides how much it wants to do. It puts it on the table. And the idea is that as countries do more and see each other do more, it leads to a virtuous cycle of increased ambition. And the overall goal of the Paris Agreement is to stop global warming by limiting temperature. And the idea is to stop warming well below 2.2 degrees Celsius, and ideally at about 1.5 degrees Celsius above pre-industrial levels. And a key point here is recognizing that we need to reduce CO2 emissions to zero. And this is where a lot of the work on negative emissions technologies comes in. So emissions actually need to drop to nil, and that's what it would take to be able to get to these temperatures. And in order to do that, compliance with the agreement requires very rapid decarbonization. And so that turns us to the energy sector, because as we know, the bulk of our emissions have come from the very rapid use of fossil fuels for the consumption of energy. Now, the future is therefore being framed by this energy problem in many ways, which is that we do require more energy, but we require more energy with fewer emissions, which is completely the opposite of how we've thought about energy and used energy for up to this point. And these radical reductions in fossil fuel emissions are required to stabilize the planet, but it's in the context of energy use that continues to rise globally. And it continues to rise because it provides energy security and underpins modern life, and it is necessary for development. So once again, we're in this sort of tension between the provision of development and quality of life and protecting the environment. It's an age-old conundrum, but it's a conundrum that's as real as it can be for us today. And some facts that highlight that are that in 2014, more than 3 billion people had no access to clean fuels for cooking. And then in 2018, for the first time, the global population without access to electricity fell below 1 billion. And that's a huge landmark, right? To be able to have that number. It's still a lot of people that do not have access to electricity. But the fact that sort of increasing energy consumption at the cost of the environment has enabled quality of life poses that sort of trade-off that we're grappling with. Now, in the meanwhile, as we think about these conundrums in academic settings, in policy settings, there is this sort of real world implication of what is going on. And these are just some images. I mean, it's always sobering and very disturbing, actually, every time I do one of these talks and I update the images, and I just always have images that are more recent from the last few months, from sort of this current moment, of how extreme weather events are damaging life across the world. The storm in Texas is one that is going on as we speak, but we have images here from the California wildfires, from the Venice floods, Chennai floods, Hong Kong. I mean, the list just goes on, and there's a sort of real shift in extreme weather events that is touching people's lives that, that we often sort of dehumanize when we think about energy and climate change in terms of our models and scenarios. Now, the big question is, can climate change be solved? And the categorization of climate change in many ways is this super wicked problem. Now, a wicked problem is a problem that that is not easily solvable. It doesn't have boundaries. It has many interrelated elements. And therefore, climate change is called this wicked problem. In fact, it's called a super wicked problem because it's a complex problem of interrelating human dimensions. And these are economic, political, social, and then biophysical elements, right? So the atmospheric, the ocean, the biological. And these systems are interconnected. They speak to each other and they feed off each other. The question about whether climate change can be solved is one that we've all been working on for many, many years now. And the IPCC 1.5 degree report models this for us. And essentially, if I distill this graph on the right, which are the 4 different scenarios in which we can stay below a 1.5 degree warming world, there are 2 ways in which we can achieve these temperature goals. One way is to be able to invest in negative emission technologies. And we had a very interesting talk before this that spoke about that. And the second is by reducing demand, by reducing energy demand. Now, I'm going to focus on reducing energy demand and not on negative emission technologies, A, because we had a great talk about that before, but B, also negative emission technologies are, it's likely they're going to be necessary, but at this point, they are not available at scale. And that is sort of difficult because requiring emissions to drop at the speed and scale that is necessary would mean having those technologies available. And right now, for the most part, those technologies are not available at scale. So instead, we have the option of reducing energy demand, but that is an option that is often very sort of, it's sparsely explored. And reducing demand is interesting because it's not just in the hands of national governments and international organizations, but it's in the hands of individuals. It's in the hands of communities, of companies, of investors. And there is a sort of a moment there for us to be able to focus on consumption. And as we see from these scenarios here, that there is actually a scenario under which we could meet our targets just by focusing on reduced demand. Now let's talk about reduced demand in the Indian context. And there's this particular duality that marks India's climate change approach. And as some of my colleagues have called it, India can be considered an emerging power, or it can be considered a premature power. An emerging power because it has a high GDP, it has high emissions, it is ranked and negotiates with many of the wealthiest countries in the world. And if you see on the graph on the left, China, the US, India, these are all top emitters and are often clubbed together when we consider climate politics in particular, but also for many other types of geopolitics. At the same time, India is often also considered a premature power. And the reason for that is if we look at it from the base of development, it is actually, it's a country that doesn't score well. I mean, in terms of its multidimensional poverty index, India ranks very low. In terms of its vulnerability to climate change impacts, it ranks very high. So it has a population that is actually extremely vulnerable to climate change. And again, if we look at population and emissions per capita, the number is extremely low. So this is the graph on the right. And India's per capita emissions are actually much lower even than the global average, right? So you have this duality where India can be both a wealthy country and a country that is actually not doing well on development indicators at all. And it has to navigate that complexity as it thinks about how to address climate change. Now, that complexity is about to get a lot more complex because the country is in the midst of many impending transitions. And these transitions are not separate from each other, they're interrelated. I'll list some of them here. The first is an urban transition. So The largest and fastest impending urban transition in history is currently going on in the country. The urban population is expected to double from 2014 to 2050, and about 200 million more people will live in cities by 2030. At the same time, there's an infrastructure transition going on. So the one of the numbers is that 2/3 of the buildings that will exist in 2030 will be built in the 20-year period between 2010 and 2030. Now, in terms of jobs, one of the numbers that we hear is that 10 million new people will enter the job market annually in the next 2 decades. This is a pre-COVID number, but even so. And until a few years ago, 800 million people lacked access to clean cooking fuel, and about 300 million lacked access to electricity. So what all of this means is that there are real uncertainties that are posed by the pace, the scale, and the scope of these multiple and simultaneous transitions. And each of these transitions has huge implications for energy consumption and therefore for climate emissions or carbon emissions and greenhouse gas emissions. And so there's this sort of, it's a system that's in so much flux where we are not sure what the outcomes will be, and there are multiple competing things going on at the same time. Now, some examples of these uncertainties that arise and how they show up in the energy trajectory in particular are as follows. One is that, it means that India can end up with multiple energy supplies futures. Is it going to be a coal-based economy, or is it going to be a renewables-based economy? At present, coal is a large part of India's economy, and this is necessary because, once again, it's necessary for development and providing energy for quality of life. But the rate of decrease in renewable prices is so dramatic that renewable electricity and renewable integration with the grid is currently met with so much success that actually there's parity between solar prices and coal prices. And so once again, the future is sort of this, it's open in terms of whether it is going to be an energy future that is made up of coal or made up of renewables. Similarly, about energy demand, the future could be based on an extremely urban, the future will be extremely urban, but this urban future could be beset with energy efficient infrastructure or infrastructure that is not energy efficient. Similarly, the economy could be manufacturing oriented or service oriented. And ultimately, that trajectory in terms of is going to be determined by the choice that is made about how we provide energy for quality of life. So the bottom line is that demand will grow. Energy demand will grow, which means emissions will grow, but the magnitude of that growth is amenable to intervention. And that makes, that's a really interesting crossroads to be at, because it sort of allows the country to be able to grow in terms of providing quality of life, but do it in a manner that is also consistent with addressing climate change. And how to do that is the big question ahead of all of us. So this is really interesting for me because Tim had exactly the same slides, and it made me think either it's great minds that who are thinking alike, or it's two people in an echo chamber, and I'm not sure which one it is, but let me repeat these graphs because they were in my presentation already. So where are these socio-technical tipping points? And as Tim has explained so well, there's, tipping points are those moments where you have nonlinear change in complex systems where one small trigger creates a sort of disproportional response. And this happens not just in our physical climate systems, it happens in our social worlds, because our social worlds and our political worlds are as complex as the sort of the science of how the earth works. So I always find these images to be, to help explain that how easily shifts can happen. And as we now already know, this is New York City, and it's Fifth Avenue, and it's Easter Day Parade. And you see on the left the images of horses, and how most of these, the street at that point was full of carriages. And then that same street 13 years later was full of cars. And that's how we would describe a tipping point, right? Where very quickly there's a big shift that happens. And our job, in some sense, is to be able to identify where those tipping points are in our physical systems and in our social systems, so as to move the entire system of systems in a direction that is compatible with addressing climate change. So I'm going to argue that these opportunities lie in our demand trajectories. And and I'm arguing this in the context of India. The reason I think so is that, one, we're at a place where structural transitions are happening, and the beauty in some sense of structural transitions, or when you're building parts of the economy for the first time, is that they are among the longest lasting components of the economy, right? So once you build roads, once you build buildings, these stay for 50 years, 100 years. But at that moment where you're building these for the first time, there's an opportunity to lock in a particular type of pattern, to lock in a particular type of behavior, to lock in a particular type of institution. And because India is at that moment, there is an opportunity here. The other reason why I think that these opportunities lie in energy demand transitions is that we now know, and this is global work that we did for the UNEP Gap report, which came out in December last year, is that approximately 2/3 of global greenhouse gas emissions are connected to households. And that's a very large number. That means 2/3 of all emissions are tied to you and me, and, and to the homes that all of us live in. And so changes to lifestyles are necessary to reduce emissions and to understand them. The other number that comes out of our work in the UNEP Gap report is that the three sort of large sectors that contribute about 20% each to global lifestyle emissions are mobility, the residential sector, and food. And so using those three as sort of different spheres where we can then look more closely and find tipping points is one way to move forward in finding a solution. Now, the way that we think about these tipping points or mechanisms for transitions within the social and political sphere and economic sphere is we do this again in the context of the UNEP Gap report. And what we do is we think about it in three large buckets, but our overarching point here is that individual change and systemic change are interrelated. In fact, they're two sides of the same coin. So you cannot, so this idea that tipping points will come top down from the government, and as individuals, we don't have anything to do with that, is incorrect. And in the same way, the idea that individuals, will make change that will be sort of divorced from what's happening at higher levels of governance is also incorrect. But in fact, individual and systemic change are always interacting. And individual choices actually operate within the broader context that enable or constrain action. So physical environments, cultural conventions, social norms, policy frameworks, these are all things that enable or constrain individual choice. And similarly, individuals can bring about social change because of the various roles that they play as consumers, as members of organizations, as individuals who participate in social movements. And this can happen in three broad categories. Now, in the structure, I'll just give some quick examples. So in the structural category, for instance, let's look at infrastructure. So infrastructure is, it's a systemic category, but it actually shapes individual choice. If I want to be able to use public transport, but I live in an area where there is no access to public transport, the likelihood is that I will not do that and will have to invest in some mode of private transportation because my choice is constrained by my infrastructure, right? Now, in the social context, what we have a lot of studies that actually show that the choices that we make in terms of environmental behavior are often influenced by our interpersonal relations. And we see this in the uptake of solar panels, where there's this real neighborhood effect. When you have a successful story about using solar panels in a neighborhood, many people see sort of, an uptake of that type of appliance. And at the same time, when we see people who are like us making environmental choices, it's likely that we end up making similar choices. So there's a lot of work actually that is done within this context of how social movements, social norms, social conventions, and interpersonal influence create those tipping points that cause larger environmental change. And similarly, in the personal sphere, the role of knowledge and information, for instance, is key. There are multiple studies that tell us that when you learn about the benefits of energy efficiency, for instance, there is a difference and a step change in the behaviors that follow. Now I'm going to give three examples before I close. And these are all examples for the Indian context, and the examples of what can be termed as tipping points in some sense, but they're more than anything else, the examples of how rapid change has happened. The first is the example of LED bulbs, and this is work that we did. Actually, this is work that I've done with my colleague Nilanjan Sarkar, who's based at Ashoka University, and this is work in Rajkot in the western part of India, and low-income housing. And it's a long study that's trying to understand energy consumption. And what you see with the top graph here is that on the x-axis is the assets percentile, and all you need to know about this graph is as you move to the right, people get wealthier, households get wealthier. And on the y-axis is the probability of these households of owning a particular type of lighting. Now that lighting could be an LED bulb, an incandescent bulb, or a CFL bulb. And this is sort of, this housing is actually in the outskirts of the city. It's not that well connected. But what we see is that most of these homes, even at the lowest income level or the lowest asset percentile, so if you're looking at, sort of the left-hand side of the x-axis, most of these homes own LED bulbs. And this was a bit shocking for us because that's not even the case in the United States or in the UK, right? And this is an extremely energy efficient bulb. And then if we go and examine what's happening at the national level, what we see here is that this is lighting market trends in India in the last, sort of 8 years from 2010 to 2018. And you see that LED bulbs, which is the yellow line, in 2014, there were almost none in terms of quantity of sales. And in the last 4 years, there's been almost a 500 times increase in the amount of LED bulbs sold in the market. And they have now overtaken the total number of incandescent bulbs. And this is actually astonishing. It's astonishing even in terms of technological change in developed countries. And this came about both as, it's a product both of policy influence, but it's also a product of uptake by households and the way they related to getting this new appliance and seeing that it's efficient and works well. And also there was a large role of awareness that was sort of spearheaded by the government, but then put in place by many other folks. Now, another example is an example of cooling, and this is another area where we do a lot of work. Cooling is really interesting. It's really interesting from the Indian context because one of the most staggering statistics around cooling is that globally, it is predicted that 10 new air conditioners will be sold every second for the next 30 years. This is a mind-blowing number. And India it has the largest population at risk of buying least efficient appliances, and a lot of these air conditioners are actually going to be bought in India. And so the future of cooling in India presents one of the most significant levers to shape energy demand, not just in the country, but also globally. Now, if you look at this graph here, and this is work in progress, so please do not cite it or use it. But as we're developing this work, what we see is that on the x-axis, you have an asset score, which means households get wealthier as they move towards the right-hand side. And on the y-axis, you have probability of owning an appliance. And if you focus on the AC, which is the curve, the blue curve that I've drawn the red circle around, you see that most households, as they get wealthier, they own an air conditioner. But what's interesting is if you look at the line that is dipping down, most of these households then get rid of owning an air cooler. And we see this is actually work that was done for the city of Delhi. And we see this tipping again happening very clearly, which is that as households get wealthier, they no longer want to use an air cooler and they want to use an air conditioner. And the energy implications of that are orders of magnitude different, right? And it is this sort of tipping point that is taking place. At this point, it's very problematic because it, sort of the implication in terms of energy demand is huge. And a graph that shows us that is that this one on the right, where we actually see that, by the end of this century, if we continue on the path that we are, the energy demand from air conditioning is going to be much, much larger than that from heating. So this is actually, again, it's a really complicated socio-technical problem. And we have a whole program on the future of cooling at Oxford where we're looking into this. And then finally, another example of these sort of tipping points is when we look at cities at sites of climate politics. And when we look at these, climate protests that happened about a year or two ago, it was actually really, really amazing to the extent when I saw these images of, cities, whether they were in the US or in Europe or in African countries or in India or beyond, there was this sort of blurring of that distinction between developed and developing countries that has plagued climate politics for so long. And instead you saw these images that looked almost identical no matter where they were from. And, sort of that one moment of a young girl, in Sweden, sort of standing and protesting around the school triggered this moment. And it means the system was ripe for it, right? It was, that same event at another time may not have had this cascade effect, but the system was ripe and to be able to tip over and create this sort of response in cities around the world and in India that has changed the conversation. So I will end there. There are a few things I'd like to say as I close. One is that India is poised at the edge of an energy transformation, which is both one where there are enormous unmet needs for development and for energy, but we're also at early stages of end use and energy infrastructure development, which poses many opportunities. And the question is that can we reimagine these transitions, particularly to take that consumption perspective and therefore lock in a different type of trajectory to the one that we're on? The other question I want to pose, and this is in light of this new center that I'm so delighted about that is starting at Ashoka, is, what is the role that our universities can play in nurturing this sort of ethical imagination with our students? And how do we do that by maintaining both hope and action, right? How do we do that without filling students with dread? And finally, I'd like to end with what I find, a really powerful quote by Mike Hume, which is that climate change is not so much a discrete problem to be solved as it is a condition under which human beings are to make choices about the way we live and govern ourselves. Thank you.
Thank you very much. That didn't disappoint. That was fantastic. So let's go to some Q&A, and it would be inappropriate of me not to give the first question, although she wouldn't want me to do this, to Professor Sarkar, our VC, who was right up with a very early question about how do we communicate reducing energy demand as the smart thing. It kind of prejudges a little bit the next panel session, but how do you see that aspect of it communicating, reducing consumption basically?
I'm so sorry, and I think it dropped off for a minute.
I can ask it again. The question about how do we communicate reducing energy demand as the smart thing? What's your take on that?
Yeah, no, thank you for that question. And so I would take that question back to the image I had shown about the different ways in which you create influence within a society, and that is using social influence, using the role of, often of influencers, so people who have a larger voice, right? The role of education in terms of the work we do in universities, but also in terms of regulations such as energy efficient labels, and sort of promoting that knowledge. So what happened with LED bulbs was it wasn't just that these technologies entered the market. There was a large campaign that went around educating consumers about why this was useful. And what's also important is the moment in which that information is provided, right? So what is that tipping moment? What is or sometimes we call it sort of, what is that moment of disruption? This can often happen when people are moving home, because then you have to like remake choices for the first time, right? So spending a little more time identifying those moments of disruption, identifying ways to educate and how to treat different communities differently. These are the many ways in which communication around demand can happen. And I think also sort of, changing that narrative that climate change is not something up there that governments will solve. That's why that interrelatedness between what is systemic and what is individual is really important.
We've got some great questions here, and I'm not going to be able to get to most of them, but here's one that I think you'll enjoy, or the really quite contested. India has already poor infrastructure, especially in metropolitan cities. Will it be possible to improve the infrastructural capabilities of the country without causing adverse social problems? So this is this question of maladaptation here, but such as displacing people.
It's a really important question, and that's the burden, right? The burden is precisely to be able to do that. That how does one meet what we call multiple objectives? And the multiple objectives are of upgrading infrastructure, but also of sort of preserving quality of life and preserving livelihoods, preserving homes. And it's not that it's difficult to do. I mean, the question is like, do we have the institutional capability and the priorities to be able to do it, right? It often comes down to that, in terms of not that we don't know what the solutions are, but do we have the capacity to implement it? So I'm posing more problems than providing a solution, but I do think that that's the way in which this, that's the way through here.
And I'd like to just squeeze this one in, although it's another complicated question, and it in some ways overlaps with the previous one. Energy consumption reveals massive inequalities. The rich at any level, national, urban, are guilty of the largest emissions. They're the highest emitter. Doesn't a transition to low energy lifestyle involve tackling inequality as well?
Yeah, thank you for that question. And if it hadn't been for time, I would have shown the slide. So what we found in our work with the UNEP Gap report was that the top 1% of consumers emitted more than 2 times the bottom 50%, right? I mean, this is, again, it's a staggering number. It's the top 1% are emitting more, using more than the bottom, twice the bottom 50%. Now, what's good in a way about this number is that it's a global number, and it shows that when you look at things from a consumption point of view, it's not about sort of country A versus country B, but it's actually that these sort of top level of consumers exist across countries, and there is disparity within countries as well. And so we cannot, sort of resort only to saying that it's not about the developed versus developing world anymore. It's sort of looking at consumption at emissions from a consumption point of view, where you do have the top 1% emitting so much more. And so the burden is very much on getting those emitters and those individuals and households to reduce their emissions so that the others can rise.